My name is Laurie Santos. I'm an associate professor of psychology at Yale University. So the Capuchins that we study are really distantly related, but they're actually a great model for human cognition for a couple of reasons. One is that being a primate that kind of branched off about 35 million years ago, they actually tell us something about what human evolution, human cognition probably looked like a really long time ago. So it actually gives us insight not just into our very recent phylogenetic past as studies with chimpanzees might do, but Capuchins actually tell us something about, really phylogenetically old similarities that we might share with other primates. One cool thing about primates is that they, like us, are extremely social creatures. So they grow up in the context of social groups, they're around other conspecifics, other individuals of the same species, and the social relationships they form really affect their entire lives. So it affects, what kind of food they're going to get, based on who they hang out with and what rank they are. High-ranking individuals have easy access to food, whereas low-ranking individuals might have to wait their turn. It affects the kind of mating success they can get, the kind of alliances they form, and the way they sort of set up their little social groupings actually can, affect just how well they do in terms of natural selection. So social groups are really important for most primate species. One of the reasons it took scientists so long to figure out how to ask monkeys about what they know about other minds is that oftentimes researchers were trying to set up studies that might make sense to a human but probably don't make sense to a monkey. So one kind of study actually involved a setup where a human was trying to help a primate get a piece of food that was hidden. So different pieces of food are hidden, the monkey can't see where they are, but the human was kind of looking and pointing at one of these pieces of food. In general, primates did really badly on this, embarrassingly badly. Even with training, they kind of never got it. But that actually makes sense. Like, never in a monkey's life would it ever intentionally cue a human experimenter to where a piece of food was. It was just a situation that was totally weird. So the insight that we as scientists had was that, well, let's use the situations that monkeys are naturally using to deceive us. Maybe this is where they'll actually show us they understand something. And now 5-10 years later, there's tons of studies suggesting exactly that. One reason it's important to actually study the evolutionary origins of, say, our economic troubles and so on, is that oftentimes when we learn some behavior or some bias is built in by natural selection, it means it's actually really hard to overcome. So, it's really hard to convince people that cheesecake doesn't inherently kind of taste good, right? Sugary, fatty things are just built in by natural selection. We're going to like them. By the same token, it's really hard to convince people, not to flinch when there's kind of some moving object coming at your head or, some scary spider or so on. These are these kinds of biases that are built in via natural selection. They're pretty old, and they're also really hard to turn off, even when we're aware of them. The problem in the economic domain is, my guess is that the biases we're seeing in us and in monkeys are going to be equally hard to turn off. But these are ones that it's hard to even be aware of how strong they are. So I think one of the important things about seeing these kinds of errors in monkeys is just not only are they old, but they're going to be really hard to get over. So policies that try to deal with these biases might be well served to say, look, let's just assume these biases are in place, and how can we design policies that can accept them and sort of deal with them as they are. One thing we're really interested in is whether monkeys have the opportunity to think twice, right? We can, experience this bias and succumb to it, but we can also be very meta about it and think about, I can talk to you now about these biases. The monkeys probably aren't, sitting around in the forest talking to each other about the kinds of economic biases they have. So the fact that we can kind of think twice, pause, kind of inhibit the sort of prepotent or the sort of instinctual bias, that gives us a weapon against these sorts of biases. But in some sense, we have to know they're there in the first place to actually implement these kind of, wait, let me stop, pause, think about it, and try to come up with the right decision. So I think awareness that we have these biases in these everyday situations and that we're really affected by them is actually very important. Our newest line of work is actually trying to explore whether or not the monkeys share some of the aspects of human social cognition that we're not very proud of. So these are things like the fact that we are very, very prejudiced, even when we don't realize we are. We have these implicit biases against outgroup members, against individuals of different religions, different races, and so on. And these biases play themselves out in really insidious ways. We'd really like to know how these biases work, but there are lots of possibilities on the table for where they come from, right? We grow up in a biased society. There are lots of kind of cultural influences that are biases. Are these the real culprits? Or is it something a little bit deeper? Is it something maybe older that might be harder to override? So we actually started studying whether the monkeys share some of our human-like prejudice against the outgroup. Our first study really just asked this in a really simple way. We said, do monkeys spontaneously distinguish between guys that are in their in-group and guys that are in their out-group? So the experiment was super simple. We did this down at our field site in Puerto Rico where we study Rhesus monkeys. Monkeys free range around, and we sort of showed up with a sort of big billboard, which had kind of two covers at the end of it. And when we opened the covers, it had two pictures of different monkeys, one guy from their group and one guy from their out-group. And the really simple measure was, do the monkeys increase their vigilance? Do they kind of get worried about and stare at more at the guy who's in the out-group? Again, this is first trial the monkeys have ever seen this sort of weird billboard setup. But we found the expected result, one you might expect from humans, which is that spontaneously the monkeys actually direct their vigilance towards the guy who's in their out-group. The worrying thing is this seems very similar to the way that humans can devote their attention to out-group members. And in our next line of studies, we wanted to see, well, are they just kind of looking longer at these guys, or do they actually treat them differently? In other words, do they associate them with bad things in their environment? And there's a long line of studies in people trying to look at whether people do this implicitly. There's a study known as the implicit association test, which basically asks you to do a couple categorizations. You're categorizing good and bad words, and you're also categorizing in-group and out-group members. Say your religion versus a different religion. And using this task, researchers have shown that it's actually very hard to categorize your in-group with the bad words and your out-group with the good words. You're actually slower and you make more errors when these categories don't match up. Suggesting that even though we don't like to think we do, we have these biases against out-group members that can play out in these really simple contexts. So we basically did the same categorization measure with our monkeys. We gave them kind of a series of different pictures that either matched in their valence, so they were all kind of good images to the monkeys, or they were all bad images to the monkeys. And the idea is in those cases the monkeys should get bored, kind of good thing, good thing, good thing, or bad thing, bad thing, bad thing. Or we set up a list of pictures where the valences differed. And one of these cases was one of pictures of their in-group members and pictures of bad things, in this case, scary spiders. And what you found is that when the valences were inconsistent, so in other words, when the in-group members were paired with these bad spiders, that actually increased the monkey's processing time, suggesting that they don't treat those categories the same way. However, when you put out-group members with bad things like spiders, they actually process them very quickly, suggesting that to a monkey, a member of its out-group is basically, in some sense, equivalent emotionally or in terms of its valence to this scary predator spider creature. Same thing when we tried to look at positive images. So in-group members, the monkeys seem to process like fruits, really positive, good images that they want to approach and come near, but not so with out-group members. So when you give them pictures of out-group members paired with fruits, it actually takes them a lot of processing time. What it seems like is that spontaneously the monkeys are setting up the same associations that we humans are, where they're treating out-group members like negative things and in-group members like positive things. For monkeys, in-groups and out-groups are very simple. For humans, it's not that simple, right? We can form groupings based on all kinds of, really stable social groups like our race, our gender, and so on. But we also form groups, on the fly. We can be Red Sox fans or Yankees fans. I could be the gray shirt-wearing person. You could be, a different color shirt-wearing person. Humans can turn these things on really spontaneously. For the monkeys, it depends on how they're born. So the monkeys in this population are born into a particular social group. It's based on who they're related to, so they're born into a particular group. The females stay in that group for their whole lives, and the males actually switch groups. So the monkeys provide this really cool window because the females live in these very stable groups that they're going to be in for their whole lives, where the males actually switch. And so the males actually, are in one group for a certain stage of their lives and then switch to a new group. So they kind of, in some sense, have to update their information about what group they're in, who they like and who they don't like, and so on. Our conclusion from this recent line of work suggests that first, that monkeys actually spontaneously form associations, form categories about groups in the same way that humans do. So perhaps the exact same thing that humans do when they think about individuals from a different race, the monkeys are doing when they're thinking about individuals from a different social group. Beyond just the fact that they categorize them, they also seem to valence them in the same way as humans do. Namely, they tend to think of the in-group as a positive entity, maybe actually devote resources more to the in-group, and they think of the out-group as a negative entity. The thing in humans is that we know that this is true implicitly. Often explicitly, people won't express these prejudices. But it suggests that whatever's going on at the implicit level might be a process that's evolutionarily quite old. And to us, that suggests that getting over these kinds of biases might even be harder than social psychologists have thought before. The monkey work is cool because what we think it's telling us is something about the roots of human sexism, human racism, human ageism, basically any form of human groupism. We're seeing the undercurrents of this in the same cognitive processing we're studying in the monkeys. The primate researchers are also a little disingenuous when they talk about primate tool use, because the kinds of tools that primates use tend to really impress us. First of all, they use tools, which we didn't think they did, over 40 years ago. Now we see evidence that they use tools in all kinds of different contexts, tools to get at food, tools to attract other mates, tools to kind of sponge off seats and climb up trees, tools for all kinds of different things. They even seem, in some cases, to have tool kits. So kits of tools that they'll use for one particular function, where they'll use different parts of the same tool and multiple different tools. And this really impresses us. But this is kind of the limit of it. There's nothing like the kinds of complex tools or technologies that we see in humans. So one way to classify the difference is that primates actually do seem to use tools, ones that are relatively complicated for other species, but they don't seem to have technologies in the ways that we do, in the sense that they don't have a sort of cumulative evolution of different tool cultures that in some sense take on a life of their own, where multiple individuals are contributing to this. The kinds of designs that we come up with in one generation get passed on and improved on by the other generation. Again, you see little bits of this, but nothing at the scale that we have in our own species. It's still a big puzzle as to why we're the only species that has cumulative technology in the way that we do. One answer that seems to be coming up might have to do with the way that humans imitate other individuals. So there was recently a study by Andy White and his colleagues trying to look at the ways that human children imitate a person acting on a tool versus the way that chimpanzees imitate. And so the experiment went like this. Both children and chimpanzees were given a little puzzle box. It was opaque, they couldn't see how it worked, but they get to watch a human demonstrator open it up. And the steps to open it up were of two parts. First, it involved kind of tapping the puzzle box in the top in this sort of way, and then it involved opening a door and taking out a treat. So both kids and chimpanzees, after seeing this, can follow the experimenter perfectly. So they do the tapping part, open the door, get the treat. Now you do the same sort of setup, except instead of the box being opaque, it's now transparent. And it's obvious to both the child subjects and the chimpanzees that the whole tapping part at the top is just bogus. Like the tapping doesn't actually go anywhere. It's like kind of a false top. So you can see as you're watching a person do this that you don't need to do this. All you have to do is open the door. When you give this puzzle to chimpanzees, they do what you might expect to be the smart maneuver. They just kind of cut to the chase and open the door and take the treat. When you do this with human children, however, what you find, surprisingly and perhaps embarrassingly for our species, is that the human children slavishly imitate the person they see. So even though they can clearly see that this, poking in the top is a stupid gesture, they do it anyway. What it seems like is that humans really are paralyzed by watching the actions of others. It actually seems to change our causal intuitions about how different objects work. This is bad when people do really stupid things on boxes and open them the wrong way, but it's great for the cumulative evolution of technology because it means you don't have to know the physics or the causal aspects of how something works. You just basically follow somebody's actions, do that yourself, and then you can pass on these kinds of cultures to the next generation. So in some sense, the fact that chimpanzees don't rely on social information as much as they seem to rely on physics actually means they might not learn about technologies in the same fast way that humans do. Because if you think about the kinds of technologies that we deal with, they're often so physically complex that we can't explain them. I use my iPhone every day, but I have no idea how it works. I slide the little bar and that's what I understand. But for chimpanzees, all of the technologies they work have physics that are really obvious, so affordances that they could see, that anyone could see. Somehow actually paying attention to social information more than the physics might have allowed us to go beyond the kind of obvious way things work to new kinds of technologies. Oh yeah, I think science is very sexy. I mean, there are a lot of big scientific puzzles when it comes to sexual reproduction. You know, why do we choose to have sex? It'd be much easier to just kind of, bud little clone, boop, it saves lots of time and energy, waste and disease and all these things. But, many, many animals in the animal kingdom actually put in the time and energy and risk the disease and, all the pains and the heartache to actually sexually reproduce. So it's a big puzzle in evolutionary biology. And then when you start looking at the different ways animals go about sexual reproduction, all the different ways they go about finding mates and strategizing to get mates and convincing individuals to mate with them and so on, it's kind of just fascinating to see all the strategies that are out there. And in many ways, humans are real outliers in this. So it's fun to look at the kinds of techniques that we see across the animal kingdom. Well, humans are a very funny species when it comes to sexual reproduction. We're very weird relative to our closest living primate relatives, the other apes. So we, for the most part, seem to be a pair-bonded species. In other words, a male and a female get together and form this pair bond and kind of cooperatively rear their young. There's nothing really like that in the rest of the great ape species. In chimpanzees, our closest living relative, you see lots of multi-male, multi-female reproductive behavior, meaning females are mating with multiple males, males are mating with multiple females. But also in chimpanzees, you also see that males and females just aren't interested in sex during the period where females aren't very reproductive. So female chimpanzees advertise their receptivity, the period where they're fertile, by having this huge sexual swelling that kind of blows up, and males are kind of only interested during this period. Somehow humans, unlike our closest living relatives, have kind of gotten rid of this. Human females, of course, don't go around advertising with, really robust, blown-up red sexual skins when they're receptive, which is a bit of a puzzle. Why did we lose this trait just in the last 7 million years? These are the kinds of things that hang on for long periods of time in primate evolution. So the fact that we got rid of this really quickly is a bit of a puzzle. So kind of weird relative to other closely related primates when it comes to sex and our sexual behavior. Our other closest, so we have two closest living primate relatives. It's a tie between chimpanzees, so common chimpanzees, and their sister species, bonobos. And chimpanzees and bonobos greatly differ in their own sexual behavior. Bonobos are sort of the make love, not war kind of primate. They tend to be way less violent and aggressive than chimpanzees. And one of the behaviors that allows them to overcome that is the fact that they're very sexually oriented. So in a lot of the situations that would cause aggression in chimpanzees, bonobos actually resort to having sex to kind of diffuse any of the anxiety or the stress about the situation. So it's another puzzle for humans is that we have one of our closest living relatives is very aggressive, very warlike, kind of a lot of the stuff that we explicitly say we kind of don't like as much about the human species. Our other closest living relative is very peaceful, very kind of social, sexual oriented, has lots and lots of female bonds. And there's a bit of a puzzle in the field of, what parts of these two guys did the humans get? Are we more like chimpanzees or more like bonobos? Still big puzzles in the field of primate cognition. The human reproductive system is one that we don't really have a great grasp on because in some sense we pair bond for the most part, but across all human cultures there's really a push to polygyny. So in most human cultures there are at least some males who take on multiple mates and have multiple mating partners, but not nearly to the degree that you see in chimpanzees. The way you can tell this morphologically is by the size of the testes relative to body size. So chimpanzee testicles relative to body size are just like enormous. You'd blush to see the size of these things. Not nearly the same ratio as you see in humans. However, humans have a larger testicle to body size ratio than what you might see in other primates where we know the females don't kind of sleep around, like as the case in gorillas. So the human mating system is kind of somewhere in between. We're sort of pair bonded. There's this push to polygyny, so there's a push of males taking on multiple female partners, but there also seems to be a push towards polyandry. In other words, females taking on multiple male partners, or else why would males kind of grow these big testicles to kind of compete at the level of sperm? So we're this funny puzzle. In terms of why humans might pair bond, one of the pushes towards pair bonding in the animal kingdom has to do with the kind of size and cumbersomeness of your offspring. So the taxa where you see the most pair bonding is in birds. You can see this in kind of the standard sort of march of the penguins of the two parents that have to sort of very cutely take care of the kids. But it's true in birds because the offspring actually require a lot of work. They're this extremely fragile egg, that's very tasty, and you have to defend it from predators and so on. And it actually requires both parents to actually incubate the egg, protect it, and so on. The idea is the same might be true of humans. Human infants are born incredibly precocial. So human infants are born incredibly precocial, much more so than are their close primate relatives. They're pretty fragile. If you just left a human baby newborn there for a long time, it wouldn't do so well. The thought is maybe this human pair bonding actually came as a result of the fragileness of human infants, in that it might require two parents to actually take care of these offspring. But again, there are a lot of just so stories out there. It's really hard to figure out exactly why we have the reproductive system we have. And it's a complicated one that we can't pin down. The sad thing that I mentioned in my course is that we know much more about the reproductive systems of pipefish and swans and lions than we do about our own species, which is kind of pathetic. The animal kingdom is full of amazing behaviors, typically in which males are trying to attract females. So most of the time through the animal kingdom, females are the ones who tend to be very choosy. So they pick between different males based on their attributes, in part because males typically don't donate much other than their good sperm and their good genes. So females tend to care a lot about how good a male looks, how awesome his song is, how great his dance is, and so on. And this leads to a pressure for males to kind of ratchet it up and have a bit of an arms race in terms of how awesome their dance is and their song is, and so on. Some of my favorite examples of kind of males ratcheting it up are cases of there's a species known as the buff-breasted sandpiper. It's this otherwise kind of drab-looking brown Arctic bird. It's drab-looking because it lives in the Arctic, very hard to get food and do everything. But it kind of allows for its beauty to come out in really strange ways. And one of these ways is that it has an incredibly attractive armpit. So its armpit is very white, very clean, and it will do flash displays for females where males will kind of get out in a field and sort of flash its armpit. And if the females like the armpit, they kind of fly from miles and miles, and then they'll kind of do this wonderful armpit display. And the females fall for it. They think this is wonderful. But you can tell kind of which males have the sexy armpits by which ones are kind of flashing, and all the females are like ah, and so on. There are also other species in which males do incredible dances to woo females. There's a species of bird known as a mannequin in which males actually do a really elaborate dancing display that actually involves two partners. So there's a kind of senior male who gets to mate with the females and another male who apprentices with him and has to learn the dance. And the female picks on the dance of both of them, even though the senior guy gets the girl. But then eventually the apprentice will kind of inherit the dancing court and get the lady. Some of our monkey economics work suggests that the biases we see in humans, in particular the fact that we think about economic questions from a relative rather than an absolute standpoint, those kinds of biases are deeply ingrained in us, probably evolutionarily old, and hard to overcome. What this means is that we got to start taking these biases seriously, and the policy implication, or even just the implication for lay people, trying to make economic decisions, is to realize that these factors are at work. So one thing we've learned is that the monkeys actually pay a lot of attention to reference points. So arbitrary information that just sets a price for you, and you care about whether the actual price you're going to pay is less or more than that. So advertisers do this to us all the time. You can't walk into, a grocery store or a department store without seeing, was like $300, now only $199, right? We're affected by these things, even though we really like to think that we aren't. And if you think about, other things that are evolved, other evolved biases we have, like, our passion for cheesecake and our, hatred of scary things and so on, that we're really going to have a hard time overcoming these sorts of biases. And so the policy implications are first just that, should we allow these kinds of things out there? Probably we're never going to overcome that. Probably these kinds of things are going to be there. But as a decision maker, you should really realize that they're there and understand that your choices are really being affected by these pieces of information. There are a set of folks who are really pushing the view that we need to take these biases seriously. So folks like Dick Thaler and Cass Sunstein, who wrote this recent book, Nudge, that I think thankfully is having a big effect, saying that, look, we need to take these kinds of things seriously, because pretending that we don't have these biases means that we set up these choice structures, as they call them, choice architectures, that are influencing people's behavior, even though we don't think that they do. So they have a case of, consider a lunch line when you have different foods in different orders. And let's say that we could figure out for sure that the first piece of food is going to affect what you buy. Which piece of food should we put first? Well, we could be paternalistic and put the broccoli first. We could say, no, we're going to ignore that and put the cheesecake first, and so on. But one of the foods has to go first, or we have to decide to be random every day and switch it up. When we set up policies, we set up these structures that have to have a default option, that have to sway choices somehow. And so the question is, how do we want to sway them? And realizing how these biases work, and that, because of our work with the monkeys, they might really be hard to override, I think, suggests that, in fact, we need to take these kinds of policy suggestions really seriously and deal with the question that, we have to set these policies up somehow, and we know that how we set them up is going to affect choices. What should we really decide to do? There's lots of really old work in social psychology suggesting that the way other people act can have a really strong influence on us. So there are a set of studies back in the 50s about conformity. So they typically go something like this. You're in a big group of people. You're asked to make a decision about something really arbitrary that you should know, like, which line is longer, this line or this line. And what you're faced with is a group of people who are all saying the incorrect answer. And what you find is that a striking number of subjects won't go against what the group norm is suggesting, sometimes so strongly that it actually override what you actually thought yourself. So the presence of other people and what other people express as their preferences or their knowledge and so on can affect us in a really deep way. Again, typically for positive aspects, these are probably the things that allowed us to develop rich cultures and so on, but they also have a negative aspect as well. So I think the implication is that we really just need to realize that this bias is there, realize that we're affected by these things, and hopefully that'll let us get better about it. Often a lot of the biases that we study and other psychologists study, the real problem with them isn't necessarily just that they're there, that we make errors or we show these illusions and so on. It's that we really have a strong feeling that we're not affected by them. So when you show these kinds of biases and errors in demos in class, students who succumb to them are shocked, and students who just hear about people succumbing to them kind of laugh like, I wouldn't show that bias. So I think one of the big problems with this work is actually convincing people, no, you will fall prey to these things, even though it really feels like you won't. So the hope is that the monkey work shows that, if these biases are really that old, maybe they're more powerful than we thought. Maybe we really should pay attention to how they're affecting our behavior. We really are affected by our own expectations. So what we taste when we're eating a particular meal or drinking a particular wine is really based not on the actual taste of that thing, but our expectations about what we know from the past. So there's, a series of studies in the economics literature showing that if you think a wine is actually worth, $100, but it's really worth $10, it actually tastes differently to you based on your expectation, because you know something about, the fact that or you like to think that $100 wines taste better than $10 wines, so they wouldn't charge that much, and so on. So our expectations actually shape the way we experience things, not just kind of what we expect, but our real subjective experiences. So the realizing that perhaps can actually allow you to focus more on your subjective experience and maybe overcome that bias down the line. The information we pay attention to tends to be very local, and it tends to be very relative. And that can, a lot of times our decisions are so based on that it forces us to ignore really relevant historic data. So one of my favorite examples of this is that people typically invest more in bonds than they should for their rate of return, that they should be investing more in stocks. Because if you look historically over the last 100 years, there's on average about a 7% extra boost that you get to your investment by investing in stocks rather than bonds. However, people don't pay attention to investments over 100 years. They look locally, and stocks have the unfortunate thing is that they often go up, but they're very volatile. So sometimes you see that the stock goes into the red, and that's an extremely salient but very local and very relative situation, yet it affects our behavior a lot. So much so that a Nobel Prize winning economist who won a Nobel Prize for actually coming up with an algorithm for how you should put stocks and bonds together, when folks looked at his own portfolio, he didn't do that. He actually invested more in bonds than he should have too. So even people who should really know better, who should have the historic approach looking over long time scales, aren't. They too are falling prey to these really local, really relative kinds of comparisons.